Okay, Mr. Lincoln is back, and we are doing some more stuff with Access. We are giving you guys some quick information about Access and how to do Access databases so that we can meet requirements and possibly let you know about super awesome jobs in the future. Okay, so we just had our old database out that we were working with last week, and we were just making some changes just to make sure that everybody's on the same page. Okay, so let's take a look. So on my customers database right here, I've got customer name, ID, first name, last name, address, zip code, birthday, and amount owed. Birthday is a date and time. Amount owed is a currency data type. Everything else is a short text. So we can now go back if we've got that done. If you need to pause the video right here to update yours, go ahead and do it. But once we're ready to go back to our data sheet, we just click on Data Sheet View. And it brings us back to the data sheet. Okay. And so now we can get some people's information in these boxes. Okay, so let's say customer ID. Let me go ahead and increase the size of this so we can see things better. As far as you guys are concerned. Okay, let's say customer ID is 001. First name is good old Bob, last name Jones. Put a little more space to the address bar here. He is, as usual, he's living at 123 Main Street, as always. And now, today we're going to talk about something called relationships. Okay, relationships are how databases really make their bones and how it makes sure that things can be efficient. Now, if I went in and put in city, state, and zip code on here on every single one of these, every single time anybody's thing came up, I would have to type in the city. But what if the name of the city changed? Okay. What if the state stopped being Texas and we suddenly split in half, and then there was East Texas and West Texas, or North Texas and South Texas? Well, I'd have to go in and change every single instance where somebody lived in the state of Texas to East Texas or West Texas, wouldn't I? Every single one. Or if a city decided to split up into East St. Louis or West St. Louis, I'd have to change every single name on every single customer ID on there, and that'd be ridiculous and stupid. Okay? So instead, I'm just going to put in zip codes because I'm pretty sure that a zip code usually only has one city in it. And if that's the case, then we can make this a much more simple and efficient web page. Or I'm sorry, database. Okay? So let's go ahead and say 78221. It's his zip code, and his birthday will be, let's say he was born on January, so 1/22/1980. 1/22/1980. That's his birthday. And he owes us $50. Okay. So because I didn't type it in the right way, there we go. Amount owed $50. Now press tab. Takes you down to the next line. This will be customer 002. And this is going to be Juan, first name, Martinez, second name. And he is Bob Jones's neighbor at 124 Main Street. He also lives at 78221. But he is a fall baby. So he was born 9/9/1985. And he owes, let's say, $125. Okay, now, customer number 3. Julie Smith. Julie Smith lives on the other side of town. She lives on 500 Circle Street. And her zip code is 78251. Okay. And her birthday is May 5th, 2000. She's 21 this year. Yay. Or she will be in a month. And she owes us a mere $25. Okay, so we've got 3 customers here. All right. And these 3 customers have very similar information, but one of them lives in a different zip code. Okay. And also they have different birthdays, and also they have different amount owes. Now, in a database, you can do things to filter information, to look at the database how you want to. There is a filter right here. Okay, there is a filter button right here, and there are also little drop-down menus in here. So, for example, if you go to zip code, everybody take a look up here, stop typing real quick. If you go to zip code, you can sort A to Z or sort Z to A. Basically, if it's a number, it's just like largest to smallest or smallest to largest kind of thing. Okay, so A to Z would be smallest to largest. Okay, largest to smallest, Z to A. Okay, see, zip, it flips them around. Okay, now if you don't want it to do that anymore, you just click it again, and it goes back to normal, or it stops filtering. Okay, and also, okay, now you can also select which ones you want. For example, you can select to just see the people who are in 78221. If you click off of the select all, and then you select the one that you want and say okay, it just shows you the one you want to see. Okay, now if you're done filtering and you don't want to do any filtering or seeing anything like all arranged and whatnot, you can always toggle the filter and turn it off. Okay, same with our birthday or amount owed. If I got amount owed, smallest to largest, okay, I can organize them that way. Okay, or just go back to customer ID and sort that way. Yay! Okay, so turning things on, turning things off, sending, descending, lots of different things that you can do. Okay, so filtering means that you are only looking for certain things in a database. Okay, sorting means I want to see these things in order. Okay, A to Z, or biggest to smallest, or something like that. So filter, only seeing what you want. Sorting, seeing things in order. Okay, and you can do that to the database, but it is not permanent. A filter can be turned off. Okay, so for example, if I only want to see people whose birthday, whose zip code is 78221, I turn on that filter, it looks like information is gone. That is not true. I can turn off the filter, and all of that information is still there. Okay, now another thing about this is it's not permanent. Okay, if you want to see that information as it is that time, then you have to do that every single time you want to see that information. Okay, now there is other ways to see this information. You can create forms and you can create queries, and we'll go over that later. But for right now, let's just say that on this database thing right here, if you wanted to see certain information, there are ways to extract the information that you need using filters and sorts. All right, now moving on. So we said our zip code is going to be our clue as to how to make certain customer cities and states appear if we ever need to have it appear. Let's create our second database though. Okay, go ahead and close out this customer's database here by clicking on this little X. You want to save your stuff? Yes, sure, why not? Okay, close that out. Actually, Hey, Emory. Click back of the thing. Yes. Okay, and it saved it, and it's all the names are across the top now. Yes. Okay, you're good to go. Now close out on the side there. Look right here. Basically, like right here, there should be an X. You can close it that way. No, that's the big X. Open up your spreadsheet again. Yeah, in your look here. In your little workbook area, underneath the ribbon, under the ribbon, there is X's there for that. Okay, so go ahead and open it up again. All right, now create. Go to File, like up here in the tabs up here, File, Home, Create. Go to Create. Okay, now there is tables, but there's also table design. If you want to go straight to the designing of the table, okay, then you can click on Table Design. And once again, we're back in this fields area. So we're going to say zip code. Okay, data type short text, just like we said in the thing. We're going to say city. That's also a short text. And we're going to say state. Okay, also short text. Now, one of the things that you can change, everybody take a look now. Once you've got city, zip code, and city and state, one of the things that you can change down here is your field properties. When you are doing states, how many characters do we normally do for state abbreviations? Correct. What's the state abbreviation for Texas? TX, correct. What about Alabama? AL, correct. What about Missouri? MO. Yeah, it's weird, huh? What about Alaska? AK. Yes. Sometimes they're weird. Connecticut. CT for Connecticut. Okay, so we've established that our state abbreviation is a short abbreviation. Go down here to where it says field size. Do we need 255 characters to designate this 2-digit state thing, which will always be 2 digits? No. Take your field size and crank it down to 2. Now, this is a very important thing that database engineers do. They make adjustments to things like field size and property types to ensure that only the necessary amount of data space storage is used. For example, if you know that the field size of your state abbreviation is 2, and you don't need the other 253 spaces or letters that could possibly be entered in this, on the computer's hard drive, you have just saved a tremendous amount of space, haven't you? Okay? All those extra letters that would just be sitting there doing nothing, but the space must be saved for anything that's possibly going to be entered in there. You have now told the computer, I don't need all that space. You can do whatever you want with it. I just need this much space. Okay? So when you crank down on the requirements for how much space is necessary to save the information that you need, you have just made it a better database that your company can now use. Even like you can use its computer storage space much more efficiently. They don't have to buy ridiculous extra sizes of like database storage areas and things like that. And you are a very good database engineer. I want you to think about this. You may be saying to yourself, how much does this matter? Come on, Mr. Lincoln. It can't really be that much different space. Hey, think about this. Amazon, Google, eBay, all of these places that do like a billion, trillion, gazillion transactions a day. You know how much space they have to provide for server space in order to get the information that they use on a regular basis? Let me just put it to you this way. In Silicon Valley, in California, close to San Francisco, these places like Google and Facebook and all of these giant companies that use tremendous amounts of internet power, they have server farms. Okay? You know what a server farm is? Imagine this classroom. Take your desktop computer which is that square, turn it on its side. Now take all the desktop computers in this classroom and stack them up to the ceiling. Same wiring and everything, going out the back, going up to the top. Okay, now put those in every single space in this classroom that you can, with an occasional walkway about the size of my shoulders for the technicians to go through. Okay, filling an entire room with computers like that, right? Okay, now do that to something the size of Dallas Cowboy Stadium. The inside, empty part of Dallas Cowboy Stadium. Yeah, that is the kind of place that places like Google, Apple, Amazon, eBay, all of these guys, they use that kind of server space. Okay? Now, not everybody's using that much server rooms, but it's very similar, especially if you get the higher you go. Now, think about it. If you're doing a bazillion transactions a day and you have the opportunity to store 2 letters of information or 255 letters of information, that adds up pretty quick, doesn't it? You're talking about trillions or gazillions of potentially wasted data space. Okay? Now, if you are using 100 times more data space than you need to store 2-digit state zip codes, and you're basically loosey-goosey with all of your properties like that, well, then pretty soon Amazon's going to have to go buy another stadium full of servers, aren't they? That's wasted money. You know how much that probably cost? I mean, we're talking probably like $1 billion, right? It's probably like $1 billion to build something. Only like at least 100 million. Okay, it's at least $100 million to build something like that. Okay, all the computers, all of the infrastructure, all the hardware, all of the wires, all of the cooling and stuff. Computers generate heat, especially when you stack them up like that. So we're talking massive air conditioning, temperature control systems and everything like that. That is probably costing a lot of money. Okay, so good database engineers are the kind of people who say to themselves, I need to make sure I'm being as efficient as possible about these properties and making sure that I only take as much data as I need to store this information just in case. Okay? So when you've got the opportunity to take a field size down to 2 instead of 255, that's good database engineering right there. Okay? All right, now, you got your zip code, you got your city, you got your state, you've changed the field size of the state down to 2. You are good to go. Take your view and click to the data sheet view. Okay, you got to save the table first. Sure, we will call this zip codes. Call it zip codes. Say OK. Primary key defined. Wait a minute, that's very important. Go back. Go back to your design view. Okay, if you've got an automatically generated ID number, well, that's not really how we want to define what's the most important value here. So go ahead and click on the ID number, and you see how it's got this primary key listed right here? Click off of it. Okay, take that little primary key icon and click it off. Okay, now we don't need this ID auto number anymore, so we can delete that row. But you got to turn off the primary key first. Okay, so the primary key is the identifier for this table, a unique identifier. There's only one line that's allowed to have any zip code in this list. Okay, that way it makes it easy to find. It's like, hey, I need to find out what the city for 78251 is. Well, if you've got 2 78251s, which one do you give them? Ooh. Okay, so we got to make sure that only one zip code is represented on each line. So click on your zip code line and click on primary key. All right. Only one person is allowed to have each thing on each line. What's another example of a primary key, a unique identifier for you? What is something that you have that only you have? Yeah, social security numbers. What about here at school? Correct. Student IDs are unique identifiers. Okay. What about last names? Yeah, not so much, right? How many Martinez's do we have at this school? We probably have a lot, right? I mean, I have at least 2 Martinez's in this class. They're not in-person learners, but I have 2 Martinez's in this class alone. So that could not be a unique identifier. First names. I have one class where it's like I've got like 3. What was it? It's there's 2 guys named Daniel, a Danielle, and it's like, whoa. It's like, hang on here. All right, so the primary key has to be something unique to the individual line. All right, now go back to the data sheet view. Save your table. All right, so let's put in a list of zip codes. For starters, we had 78221, and that was San Antonio. And TX for Texas. Make it capital letters just to be solid. Now, you hear that? That's me trying to type more letters into this state thing right here. Remember how we told it to only be 2 letters? It will not let me type in any more than 2 letters. So press tab. And now we had 78251 was the other zip code. Let's say, just for the sake of argument, that that's Helotes. Helotes, Texas. Okay. And there's a few other zip codes here. Let's say 78215. Let's say that's Castle Hills, Texas. And 78111. That is also San Antonio. Okay. All right, so we've got our list of zip code potential possibilities here. Now, this table of zip codes, let's save. First off, let's save. Right-click on the tab for zip codes here and say Save. Right-click on the tab where it says zip codes here and Save. Emery, the tab right here. You have it? It says Save. Okay. Is everybody good here? Are we all caught up? Has everybody got it? Pedro. Put that away. Killing me, Smalls. All right. Now, if I were to take this information right now on the customers and the zip codes, so let me go ahead and increase this again because you guys can't see. Okay. We've got the customers and the zip codes and everything like that. We still have a problem. There's no linkages between the two. Okay. We have no linkages between the two. The database does not know that the zip code here is a reference to the zip code on the other table. So close all of your tables. Look, close all of your tables by either right-clicking the tab and saying close, or, Emery, look here, this little X here, do you see it? Okay, not the big X at the top, but the little X right here. You may close it that way as well. Okay, close out all of your tables. Close your tables. Now go here to this thing that says Database Tools. Database Tools. So we will now create a relationship between the customers table and the zip codes table so that it knows which one to go to whenever it needs the zip code. The more, like the rest of the information about the zip code. So click on relationships. Okay, now here is a playground, you might say. This gray area is a playground where you may have your tables out there and you may like make little connections between your tables. But you got to put your tables out there to play with first. Okay, so first up, double click on customers. That is one way to get a table into the playground. The other one is to click on zip codes and say add. Okay, now you have added zip codes to the playground. Now, be sure to click the right box. Say close. Close it. Once you've got customers and zip codes, now you can increase or decrease the size of these boxes by clicking and dragging on the edges. Okay. All right. Now, you got customers, you got zip codes. You want to make this zip code here on customers understand that it needs to go to this zip code database and find the city and state whenever it needs to. Find the correct city and state for the zip code listed on the customer table. So go to zip code on the customer table. Go to zip code on the customer table. Click and drag. You're going to get a no sign at first, but when you go over to the zip code table, put your mouse over the zip code with the key on it and let it go. Okay. Now you have matched up these two fields and basically told the database, I want you to make sure that when I say, hey, I need a zip code in a city and a state, you take this zip code, you find it on the zip code list, and you get the appropriate city state for that zip code. That is an extension of this information, so to speak. You know what I mean? All right. It's basically like me saying to Pedro, Pedro, I need information from you about certain things that you have on your list. You will tell me the things on your list and report back to me. Okay? That's the kind of thing that we're doing here. Now, do you see this checkbox that says enforce referential integrity? Check on that checkbox. The thing that happens here is, number one, you got to have the same data types for sure. Number two, on the customers table, you have to put in a customer zip code that is actually on the zip code list. If you check this checkbox, you must put a zip code that is on the list. Okay, otherwise it won't let you. It'll be like, nope. You got to choose one that's on the list, dude. So go ahead and say create. Now we have created something called a one. Look up here. We have created something called a one-to-many relationship. There are many possible zip codes that can be found in the customer database, but it is only going to match up to one zip code in the database. Okay, so it's a one-to-many relationship. Now, close this. It will ask you to save. You say yes. Okay. Now, did anything happen? No, not yet. Watch this though. I will create a form real quick. We'll talk about forms a little bit later. Okay? Yeah. Take a look. I'm going to use table customers. I'm going to say I want to see the first name, the last name, the address. Wait for it. And that's from the customer field. Then I'm going to go to the zip codes table, and I'm going to pull the city and state and zip code for that person. So I'm getting first name, last name, and address from the customer table. And then I'm using that little zip line that I've created from the zip code on the customer table to the zip code on the zip codes table. And I'm going to put in the rest of the information, the city, the state, and the zip code. Okay, next, looks good. Yes, fine, okay. All right. Oh, Bob Saget, I did the wrong thing. I don't need a form, I need a report. My bad. Delete. I did the wrong thing. Stupid. Not forms, reports. Not this way. Boy, I'm all kinds of messed up today. Hang on a second. Create report wizard. Here we go. Okay, first name, last name, address. Flip it over to the zip codes table. City, state, zip code. Next. Looks good. Yes, indeedy. Sort by last name. Okay, then by first name. Okay, say next. Tabular on a portrait thing. Sure, looks good. All right, go. Finish. Here's my report. Okay, here's my report, and I want it to look bigger. Stop being small. Okay. All right, now you can see Bob Jones, who had 123 Main Street on there, but did not have the city and state on his database listing, did he? The database listing did not have the city and state, did it? But because I linked up the zip codes, now it can go and find the appropriate city and state for this zip code and change it. Woo, fancy. Now, watch another thing that I can do. On the zip codes table, oh no, 78221 has overthrown their San Antonian overlords, and they are now the city of Harlandale. So I have changed one thing here on the zip codes database. Now I go to my report. And by the way, reports are permanent. So it's like you can always bring up the same report if you make a report. I bring up my report. And now you can see, wow. Now you can see that instead of saying San Antonio, the city says Harlandale now. Now, if I was on the customer's database and I had these city, state, and zip code things, I would have had to change them for everybody. Okay, I'd have had to change the city and state for everybody. But because I changed it on the zip code table and I have it linked up like that, they automatically change all of them automatically. All right, that's it for today. Good times. Talk to you guys tomorrow.